loads in structural systems. A structural load is a force, a deformation, or acceleration applied to structural elements. We can look in this photo, a load in a small boat that will push the element down and is creating some stress in the material. The load will cause stress, deformation, displacement in a structure. Static loads are a type of loads that are force acting on structural components. Usually, a load will tend to push the body down because of gravity. There are many types of loads. You will also find in several references and books that the classification is different. For effects of this class, we will use the graph that you are looking now. The loads will be divided into types, statics and dynamic. Statics, the ones that do not move. Dynamics, the ones that move. Dynamic loads can be continuous, like a wind, like an earthquake. During some time, it will be acting and will be continuous, or can be impact. An impact load is dynamic, but it's very short. It's like when a car just hit a building. Wind loads are a little bit tricky because they are dynamic, but in the other side, they are environmental. And environmental loads are life loads that are movable and are static loads. Well, wind loads are in between statics and dynamics, but we consider wind loads usually dynamics. That is the effect of the wind in the buildings. Again, going back to static loads, they can have several types. The building codes divide the loads in two types, dead and live. However, the type of loads are divided into types, the general type, statics and dynamic. That is very important to understand because in the building codes, we are speaking about two main loads that will be dead and live. Dead is everything that is fixed in the building, the self-weight. Live, all the things that move in the building. We will look them a little bit more carefully later on. After, we have some loads that are due to settlements or thermal effects. For example, in a bridge, because it's a very long structure, if the sun is hitting in the morning, after in the afternoon, the bridge will become bigger. A long bridge can change a lot. It can become 1 foot longer. It will move. However, after when it became cold at night, it will retract and become smaller again. Well, thermal effect is important, especially in long structures. Let's go with dead loads. Dead loads are also known as permanent loads. There are statics. They remain constant in the building. It's, for example, the weight of the building, every element of the building, from the walls to the doors that are fixed, the beams, the columns, etc., etc. Everything that is fixed in the building. Live loads are the loads that are subject to a different deal. Is the ones that are not part and are not permanent in a structure. For example, imagine that we have this bridge. In the left side, the people walking in the bridge is not part of a structure of the bridge, but they are acting, they are pushing the bridge down. Therefore, are important loads, but are live loads. Live doesn't mean that they are alive. Any element that is not fixed in the building will be a live load. This part is very important and is usually in the test. How to calculate dead loads and later on live loads. Dead loads are part of the static loads, as you know. We calculated dead load just putting together the weight of every element of the structure, from the top in the roof till the foundations. All the weight of the structure are the dead loads. It's a little bit boring to calculate the dead loads because you need to take every element of the building and give a weight. For example, wood have a specific weight according with the type of wood. Well, we will measure the dimensions of all the pieces of that particular wood that are located in a place. We will calculate the volume and we will multiply by the weight of that material. And the same with everything. From the windows, for the doors, from everything will be together, and we will put all those forces, all those weights together, and we'll have the weight of everything that composes the building that is fixed. Instead, the live loads are calculated according with the codes. For example, we have a residential building. We know the area of this particular residential building. And looking at the codes, we have that the dead load of this type of residential buildings is 48 pounds per square feet, for example. Well, we have all the area, we multiply by 48, and that is the live load. Why? Because we're not sure what will be exactly the weight of the elements that we will have in a building. You know, live loads are everything that is inside of the building that is not fixed, including the people, including the furniture, including some of the equipment that is not fixed. Well, it's just something very subjective and very conservative. It's just a particular weight per square feet. We can look here the use of occupancy uniformly distributed loads, I mean live loads, in some type of buildings. For example, this residential building will have usually 48 feet per square feet, 48 pounds per square foot. After office building 58, hospital 40, library 60, etc., etc. Dead loads then are roof, walls, floor, equipment, everything related with the structure. Even some architectural components like faucet panels, non-movable partition walls, railing, equipment, etc. Live load are elements that are in the building that are not fixed. For example, in some climates, the snow, the people, the furniture, the equipment, and everything that move, like movable partitions. Thereafter, we have wind loads. Wind loads in pounds per square foot usually are placed in the exterior part of a structure by a wind. A wind will push the building, and it may affect the shape of the structure. Well, it's very important to prevent the wind damage. Wind loads are very dangerous in tall buildings. Why that will happen? Because it will produce some kind of forces. And we can look here some of them. First, there is a lateral load. And this is a sliding. I mean, the building will tend to move. And the foundation will tend to overturn. After, we have an uplift load. What that means, the wind can push up the roof of the building and cause an effect like the wings of an airplane. After we have a shear load that is a racking, like a horizontal wind pressure that will cause racking in the walls and make the building just to tilt in one side. As I was telling you, it's very important to take in consideration the wind loads, especially in tall buildings, because they can overturn the building very easily. When engineers calculate a skyscraper, the weight of all the material that is dead load and the weight of all the live loads for furniture and people is not the most important. What is dangerous in a very tall building is the wind. Why? Because imagine the pressure that the wind can cause in this area, in the top of the building, and create after something that is called suction in the other side of the building. And because the wind is acting from the top to the inferior part, we need to multiply the force of the wind by the distance, what would cause a very strong moment in the inferior part of the building. Well, if you have a building and you move in this sense, obviously the moment is something very important. Finally, we have seismic loads. They are very dangerous. And unfortunately, they are not easy to predict. It happens when the ground moves. And we will have a specific presentation related with seismic loads. There are several types of waves, and the horizontal forces that move the building to the left and to the right usually are the more destructive. Earthquake loads are dynamic loads, and that means that the building will have some kind of vibration and will produce a lot of damage if this vibration is very fast. We have finally gravity loads that are a consequence of the gravity and are related with all the different loads that a building can have. The same weight of the building, of the people that is inside, of elements like snow, etc., will produce and will tend to create some instability in the structures. There are other loads like lateral loads, for example, or dynamic loads. Lateral loads can be, for example, when we have like a parking lot that is underground, underground parking, for example, and the dirt in the other side of the walls will tend to push the element. The earth will create some kind of pressure, and many types of dynamic loads that are related with different elements related with motion. There is more material related with loads in the first chapter of the Underwood and Cuny book, that is the general book for structures too. Please remember, you don't need to buy any of the test books. There are links in the syllabus in order to read them and be able to find them electronically through our